This thing here, my friends, is a galvanic cell. It's how we produce electricity from redox reactions. As you are well aware, redox involves the transfer of electrons from where something is oxidized and electrons are lost to where something is reduced and electrons are gained. In a galvanic cell, what we do is we separate out our two reactants. We have something that is being oxidized over this side, and then over this side we have the thing that's being reduced, and they don't come in contact with each other. We do, however, ensure we have a complete circuit, and what that allows is for the electrons to be lost from our thing here being oxidized and then transfer around here through something like a voltmeter to prove we have electricity, or a light bulb, or a phone that you're watching this on right now. And then the electrons keep on going around here to where they're getting reduced, and we have our thing that's being reduced on this side. So we end up with this flow of electricity, which is actually electrons moving around a circuit. So you can see here that they're connected with a wire. So this is a wire here that connects our two reactants. But we also have this thing up here, which is called a salt bridge. And as I said before, this is what allows us to complete a circuit to allow electricity to flow. But it's got more than that. It does more than that. It's got a lot of interesting features. It's made of a salt, which is an ionic compound. That is made of charged particles, that's why it allows for this flow of electricity, because we have the flow of charged particles. It also is here to neutralize out our two half cells. As you can imagine, electrons being lost from here over an oxidation, that would technically make this area here more positive. And we don't want that, or we can't actually have that. These solutions and these areas need to remain neutral. So therefore, if electrons are being lost from this side, our salt bridge needs to apply or provide negative charge. So in our salt bridge, our chloride ion is going to go towards the site where oxidation occurs. And the other thing is true as well. So over here where reduction is occurring, we're gaining electrons, which technically means we would be gaining negative charge. In chemistry, we don't like a lot of charges overall, so therefore, to neutralize that charge, our potassium ion in this example, or our just any positive cation, will flow towards where we have reduction occurring. The other feature that this salt bridge does is it makes sure and ensures that our reactants are kept separate. What that does is it makes sure that we actually have a flow of electrons through an external wire, and we don't have the direct transfer of electrons, which would produce heat instead of electricity.